1.4 builds on the last section. Hopefully this is still review. If not, once again, you're learning and it's good warm up, and these are foundational vocabulary and skills and topics for all of mathematics. Write equations and inequalities. In the last case, we were writing expressions. So now, instead of just saying the difference of a number z and 11, we have is equal to 35. So the difference of a number z minus 11 is equal to 35. How do I know whether it's 11 minus z versus z minus 11? That's a good question. That's why things are better in context. I'll leave it at that for now. If you check your answers and it's the other way around, it's not a big deal. The product of 9 and a quantity 5 more than a number t is less than 6. Boy, there's a bundle in there. But as soon as I see a quantity, I'm thinking parentheses, because that's a whole quantity. So I have the product of 9, so now I'm going to multiply by a quantity, so that's going to be parentheses, 5 more than a number t, 5 plus t, and then is less than, that's this symbol, 6. So 5 plus t is less than 6. Variables z and t and s and d, and some of them are very difficult to distinguish between numbers. So in the end, I don't fault students if they use x's. If a variable pertains to a certain quantity, like C for the number of cars, that's great, and C is pretty easy to distinguish, but I understand the frustration when it's hard to differentiate your variable maybe from an operation. The sum of a number n and 4 is at least, whoops, I think I copied that one wrong, is just at least 13. At least is a good set of vocabulary words. The sum of a number n and 4, n plus 4, is at least. So if I say you have to be at least 16 to go to the movies, what does that mean? That means 16 or more. So this has to be greater than or equal to 13. At least also means greater than or equal to. The product of 8 and a number k is greater than 4 and no more than 16. So here's a case where 8k is wedged between two numbers. So I'm going to write a compound inequality. It's greater than 4 and no more than. So it's less than 16 but could be up to 16. It's no more than. So less than or equal to. So you might have to play around with these and you might get them wrong, but that's why you check your answers and you correct them and then you learn from that. That's how this goes. This we're going to see a lot of throughout this course and future courses. We want to know if this is a solution to this equation. Is 8 a solution? And what does that mean to do? Just plug in and see if it works. So 8 plus 9 equals 17. Yes, this is a solution. How about r divided by 3 minus 4 equals 4? If I plug 12 in, does that work? 12 divided by 3, oops, is 4. 4 minus, this is why I use pencil. I'm using pen so you can see my answers from the questions, but 12 divided by 3 is 4. 4 minus 4 does not equal 4. Not a solution. Or no would be fine. But we look at that a lot. Does this value work in this equation? Check to see if it's a solution. Plug it in and see if it works. 2 more. Solve using mental math. How are you supposed to show your work? You can't really. Just think about it. You're thinking about the operation here. 5 times W equals 20, or what times 5 is 20, and the answer is 4. Problem solving. You buy a storage rack that holds 40 CDs. Yes, some of these questions are a little old, but I'll use it. I think it's a good example. You have 27 CDs. Write an inequality that describes how many more CDs you can buy that the rack will hold. So if you already have 27, you can buy so many more, and that still needs to be less than or equal to 40. Your rack holds at most 40, so your total number of CDs could equal 40 or needs to be less than that. And then they say you buy 15. Well, they fit. So that's like, oops, that's like saying n equals 15. Let's check to see if it's a solution. So 27 plus 15 is less than or equal to 40. This works out to be 42, I think, right? Nope, you have 2 CDs left over. That's that one.